In this next example, we want to transform the sine function a little bit differently this time. We want to actually graph the function y equals sine of theta plus 1. So last video we doubled the function sine of theta. This time we're going to add something to the end of it. So I'm actually going to keep the same parent function I had from before. I'm going to keep the same values for theta that I had before. And we're going to sketch on top of this one what the transformed function looks like. So let's actually think of what this transformation would look like. So let's actually think of the graph y equals x squared, or the function y equals x squared. The graph is your standard parabola, looks something like this. If I were to graph y equals x squared plus 1, I'm going to graph the same parabola, but I'm just going to shift all of my y values up 1. That's essentially the same thing we're doing here. We know what the parent function looks like for the sine of theta, and we're just going to move all the y values up 1, since we're adding 1 to the outputs for sine of theta. So if I construct my table then, I'm going to take what I had in my parent function table and shift them all up 1. So my first y value used to be a 0. Now I'm moving that up 1 to a 1. My second y value, when theta is equal to negative 3 pi over 2, used to be 1. Moving that up 1 to 2. And then what I'm going to do next is I'm going to move back down to my midline. So that's going to be a 1. Next, when theta is negative pi over 2, normally that sine of theta is negative 1, but when I add 1 to that, I'm going to move that up to 0. And I'll just continue this pattern in the same way. And once I graph this, it's going to look something like this. So up 1 for my parent function. All of these values are exactly 1 higher than my parent function. So something like this. Something like this, and then something like this. And so here's what my new function, sine of theta plus 1, looks like here in blue. So it looks exactly the same, just moved up 1. So the domain, that's still the same, from negative infinity to infinity. What's changed is now my range has actually changed. My range for the parent function is negative 1 to 1, but since I moved everything up 1, that moves my range up 1 as well. So I'm going to go from 0 to positive 2. That's my new range. Period has not changed at all. I've not done any sort of dilation or stretching with my x values, so this period is still going to be 2 pi. It takes 2 pi radians to get back to where I started in this wave. My amplitude, surprisingly, is the same as well. You might think that I've affected it because I've done stuff with the vertical transformation, or I've made a vertical transformation, but if you look at the distance from the midline to the maximum, it still is 1 unit high, right? So there's one unit between 1 and 2. So that amplitude is still 1. So what has changed? Really, the only property that has changed is my range. And we say that we have changed the midline in my function to y equals 1, since I've moved this function up 1. So normally the midline in the parent function is just y equals 0. If I add the function up 1, my midline is now y equals 1. So we've done a couple of transformations, and I want you to try one yourself. I'd like you to try this problem, pause the video, and give this one a shot and see how it went. All right, and here is my answer for this one. This was a little bit tricky because I combined a couple things here. I performed a vertical transformation by multiplying all of my y values by negative 1/2. So it actually made a compression with my sine wave, and then it also reflected it over the x-axis. So there's two things that went on here. Maybe you caught them, maybe you didn't. But if we were to sum this up, this negative makes a reflection over the x-axis. And let's say that this 1/2 means a vertical compression towards the x-axis. So we're really combining two things in here. I've changed the range a little bit, I've changed the amplitude a little bit, but all the other properties stay the same. So hopefully that went okay.